In this video, we're going to learn how to make frequency distributions. Before we do that, we're going to learn some common terms that you'll see when we're talking about data. So the first characteristic of data we want to talk about is the center. Where is the middle of the data? The next term is variation. How much do the data values vary? Or how far apart are they? The next term is distribution. What is the nature or shape of the data? Is it bell-shaped, uniform, skewed? And we'll learn what all of those terms mean. Are there any outliers? Do any of the data values lie far away from most of the other data values? And sometimes you'll want to think about time. How does the data change over time? Okay, so just a little mnemonic device to help you remember this. Computer viruses destroy or terminate. So the C in computer is for center. The V in viruses is for variation. The D in destroy is for distribution. The O in OR is for outliers. And the T in terminate is for time. Okay, now we're actually going to make a frequency distribution. So a frequency distribution is going to be a table that helps us organize our data to help us understand the distribution of the data. And remember, distribution is another word for shape. So here's the data we'll use in our example. So it says on a math test, the scores of 24 students were, and we have these 24 data values. So we're going to make a table and we'll have intervals. So we'll say what data value is from this number to this number. And then we'll have the frequency. We'll count how many are in that spot. So to do that, the first thing we need to do is set up our intervals and then we'll count their frequencies. So to set up the intervals, we first need to find the range of the data set. And the range is how far apart the total data set is. And so to do that, we're going to take the maximum value and subtract the minimum value. So for this data set, our maximum value is 98. And our minimum value is 64. So we'll take 98 minus 64 is 34. So our range is 34. So now to create our frequency distribution table with classes, the classes are our intervals. And we'll need to make sure that we have intervals that each of our data values fit into. Now you may have a case where you're counting something that's not numerical, something that has categories instead. And so our classes there would be the categories or the labels. Now, there's no hard and fast rule about exactly how many classes a frequency table has to have. Our book says that it's generally 5 to 20 classes, and it really depends on how big your data set is. In our example, we'll be told how many classes to use. So in our example, we're going to use 4 classes, so that's given to us. So the first thing we're going to need to calculate is the class width. This is also known as the class size. And it's very important that we know that all classes must be the same size. Otherwise, we wouldn't get a true feel for what the distribution of the data is. So the class size formula is the range divided by the number of classes. And then you always round up to the next whole number, the next integer. So we found our range on the previous page was 34, and we want 4 classes. And this gives us 8.5, so we're going to round up to 9. So we have found that our class width is 9. So now we're actually going to create our frequency table. So we first make our intervals, or our class limits. And we begin with our minimum data value. So our minimum data value here is 64. Then we use our class width to actually find the beginning of the rest of the intervals. So we're going to add 9 to get our next starting number. So 64 plus 9 is 73. Then we would add 9 and get 82. And we'd add 9 again and get 91. Now I think it's helpful just off to the side to write what your next one would be if you had another class. So if we had 9 again, we'd get 100. And you'll see why that's helpful in a minute. So now we need to fill in what our intervals are. So our first one's going to start at 64. Now our next one starts at 73. So we're going to subtract 1 from that and see that the first interval should end at 72. So the next one, it'll start at 73. We see that the next one starts at 82, so it'll end at 81. This one will go from 82 to 90. And we'll see that our last one goes from 91. This is why it's helpful to see that the next number would be 100. So this will go to 99. And now, to get the frequency, you're going to use your data set and you're going to count how many of the data values will fit in each of these categories. And it may be helpful off to the side to keep a tally. So 98 would fall in this one. 72 would fall here. 71, 64. Both 71s would go there. 98 would be down here. 84 would be in this one. 71 would be up here. So would 68. 81 would fall in this category. 72 would be here. Another 72. 81. 71. 72. 81. 71. 72. 84. 72, 81, 84, and 64. So now we would count these up. So if we count up our tally marks, here we have 15, here we have 4, here we have 3, and here we have 2. And so this puts all of our data values in nice categories, and we can see that the most frequent is up at our lower levels, our lower scores on these tests, and then it continues to go down. So we're starting high and going down, and this shape is actually called skewed right, which we'll learn a little bit later, because the tail going down is to the right. So that's our frequency table. Now we can actually make a few different types of different frequency tables, so we're going to do that now. So I'm going to go ahead and just put our table that we had here a minute ago. So we had 64 to 72. There were 15 in there. 73 to 81. We had 4. 92, sorry, 82 to 90, there were 3, and 91 to 99, there were 2. So for a relative frequency distribution, we want to know, instead of the frequency, what percentage of the values fell in that category. So our categories are going to be exactly the same if we're making a relative frequency distribution from a distribution chart. To find our relative frequency, so just think percentage here, we're first going to need to find our total number of data values we had. So you can either add these up, or if you look at the original data set, we had 24 values. Now to find the relative frequency, so the work here, you're going to take the frequency that you had for that category, so for this first one would be 15, divide that by the total, and then you multiply that by 100 to turn it into a percentage. So here on the calculator you can see that we would take 15 divided by 24, so that would be our decimal, our percent as a decimal, multiply it by 100, we would get 62.5%. So very similarly for the next one, we would take 4 divided by 24 and then times 100. You can round to one decimal place here, so we'd do 16.7%. Then we would take, the next number was 3, so 3 divided by 24 and multiplying that by 100. We see that we get 12.5%. And the final one, we have 2 divided by 24 times 100. So we get 8.3%. Now, to check yourself here, you'd want to add up the relative frequencies and make sure you get up to 100% or something very, very close, like 99.9. It could be a tiny bit off because of rounding. And the other type of chart we can make here is a cumulative frequency distribution. So these, we're saying how many are less than a certain number. So we're going to start by saying less than 73. So notice that's the beginning number of our second class. Then we would say 82, 91, and then remember before when we added 9 again, we got 100. Okay, so here you're counting how many in your data in your data set are less than 73. Well, from our table from above, well, that would just be all of them that were in the first category. Any of them between 64 and 72 would be less than 73, so that would be 15. Now less than 82 would be the ones in the first two categories, so that would be our 15 plus our 4, which was 19. Any of them less than 91 would be all of them in the first three categories, so we would add the 15 plus 4 plus 3 gives us 22. And your last number will always be how many there are in the data set if you add all of them, and that was 24. So that's how we make a cumulative frequency distribution. So we learned a regular frequency distribution, the relative frequency distribution, and the cumulative frequency distribution.